Assalamualaikum warahmatullahi wabarakatuh, and a very good day to you, Professor Dr. Shafri. My name is Aimi Binti Rusdi, and with my other two teammates, Nuramyra Natasha and Nurul Najiha, for today we will be presenting our topic for volume visualization, which is on marching cubes. So for today we will be explaining about the introduction and then the method and comparison. The fourth one is the example implementation, and lastly are the references.
Hi, my name is Nurul Najiha Binti Hamdan. Begin our presentation about volume visualization. Firstly, it's about volume visualization. It is a two-dimensional graphical representation from scalar dataset that are defined on three-dimensional grids. There are two essential types of volume visualization, which is direct volume rendering and also indirect volume rendering algorithm. We use indirect volume rendering algorithm, which is marching cubes algorithm. Indirect volume rendering technique is to generate an opaque surface model of the given volume data. The coherent structure for example, skins and bones are represented by point set with the sampling rate. Next is the surface of the point set are estimated by polygon or triangle meshes. This algorithm is chosen because of fit advantage, which goes through all voxel, which is cube. We are talking about marching cube right now, so it will go through all voxel in the cube. Marching cube is a computer graphic algorithm that creates and extracts the triangle model of constant density surface from 3D medical data. The approach for this algorithm is divide and conquer to generate the interslice connectivity in defining the triangle topology. Divide and conquer approach is locating the polygon surface in a logical cube created from 8 pixels. Discrete marching cube also acts as a tool to construct image and display ISO surface at high resolution. The industry that has been using this algorithm is medical industry for medical visualization and imaging, such as a CT and MRI scan to process the data images of interior part of body for clinical analysis in a short amount of time.
Assalamualaikum and hi, my name is Nuramyra Natasha. The first step is we need to identify the cube by 8 points of value. So the first point is start here, which is I, J and K. So I represent as X, J is represent for Y and K is for the Z. The point is based on base point to generate another points. So start by adding 1 at every point. For example, I plus 1, then J plus 1 and so on to the total of 8 vertex. So in the step 2, we create and classify the index to estimate of each cube in the object. It is determined in which point is inside and outside the object. When the ISO value is less than, it is inside, but when the value is larger, it is outside the object. In the step 3, we create binary labeling for position. It is basically for just a name for the two conversion, which is inside and outside the cell. It has to be calculated until all the point inside object to render the cubes and also object. The step 4 is store given index in array. From the given index, we have to generate 256 cases into array. However, it is impossible to store all of it as it will consume a lot of computing power. So based on the symmetry, only 15 bits can be used. So we need to retrieve in particular index to generate a surface plane using the reduction technique. So how do we identify the reduction techniques? Is by using divide and conquer. So from the third step, we have determined the in and outside the object. Then the triangle is used to divide the cube, which is combined as a one plane. So next we have case reduction, which is value symmetry, and rotation symmetry that will perform the rotation to switch the inside and outside by switching the negative and positive position. So step 5, we need to find the vertex along edges using a linear interpolation. So it is to determine the triangle is facing in which direction. So step 6, we have to calculate the normal at each vertex of the cube. From the previous triangle, we have interpolated a surface of object. So every surface, we need to calculate the normal. Previous vertex minus with the current vertex. Then the cube must be changed according to the generated basis. So linear search need to go through all cells line by line to perform the volume visualization, and then it has to compare the maximum and minimum of ISO. Step 7, we have to consider the ambiguous cases. It is hard to identify which cube belongs to which, so we need to generate another plane and case to add on it to look the table. So it has been solved by using the hyperbola function.
Next part is about comparison between marching cubes and also marching tetrahedra. Marching cube works, it is marching through the whole volume dataset and subdivide space into a series of cubes. While marching tetrahedra, it is splitting the cell into tetrahedras, which is easier to handle. It involves 8 vertices because of cube, while marching tetrahedra, it involves 4 vertices because of the triangular pyramid. Okay, the number of cube involved, it involves 1 cube only for marching cube, while 6 tetrahedra to complete 1 cube. Okay, for the rendering, marching cube, it can triangulate in 256 cases if possible, but the process is kind of slow and can cause the error. For the marching tetrahedra, it is very effective and fast, which can reduce triangle by 70% generation. For this illustration, we can see that there is 15 cases from 256 cases. There's 15 cases which have been reduced, have been triangulating in marching cube, while marching tetrahedra, the triangular pyramid is splitting to 5 to 6 cells.
I will proceed with the example implementation of marching cubes. For the picture, this is a 3D rendering picture of a human face. So the marching cubes method, it keeps the coordinates conveyed by traversing the outline of the 2D binary shape and then marches them, makes the marching cubes to construct into a 3D object. For example here, the 3D human head model is constructed by the marching cubes method, which uses 150 slides or slices of 2D image as an input source. So how it is implemented is, for example, the CT scan for 3D rendering. So obtaining the intensity value of medical images, it begins with by reading the coordinates and values. So then it will store the data in the structure of the system. So in medical field, they will use this because the image provided will be very smooth and it's very clear to see any diseases or problem in the human. Then after they store, they will input the array and it will be manipulated by the marching cubes as well as the histogram pyramids to smoothen the picture. So here is an example on the right. It is a CT scan of a human brain. So this is the example of the store data where it is in array system. So then the data will be kept in array and the intensity value of the input image will be in grayscale image or the range of grayscale values from 0 to 256. Next is a 3D medical visualization where the program may prompt the user to rotate the result of the 3D object. So the histogram pyramids and the marching cubes will be combined to provide a smooth scan, as you can see in the picture on the right. That's why medical fields will use these methods. So next is the MRI and CT scan. So the histogram pyramids, they use this because the histogram pyramids can reduce the redundant voxels, which is not used for generating the 3D surface. Then here below, it shows a comparison of the surface rendering between the marching cubes and the marching cubes with the histogram pyramid. So on the left is without the histogram and on the right is with the histogram pyramid. So as you can see, the picture is much more smoother and you can see it looks more realistic. That is all from us. Thank you very much. Assalamualaikum.